On today's episode. Welcome. Here I'll show repairs I've done and share the techniques and tools that I use. If you find this video valuable or even entertaining, please subscribe as it really helps. It's great to get your feedback, so leave a comment below and don't forget to hit that like button. Also check out the description below because there'll be additional information and some useful links. So it's been a little while since I've assembled a kit, and there is some method in the madness. I'm going to be doing some Arduino type projects, and I thought it would be useful just to have a little oscilloscope on the bench, just really to check, you know, if you push a button that the logic levels are changing or that something's oscillating. Now I do have a very nice oscilloscope, but it's a bit of overkill for what's needed, so I thought we'd build this kit and see if that works for us. Now the kit comes with comprehensive instructions and assembly guide, so we'll step through that, and the case looks very nicely made, and if we take a look inside, we can see the various bags of components and things, and we'll follow the instructions to assemble it. Most of the really difficult stuff has been done already. You can see there a very nicely laid out surface mount board, and what else do we have? All sorts of goodies. So we've got all the hardware included in the screen. So before I lose anything, we'll get the instructions out and get this thing put together. Just lastly, yeah, it does come with at least one probe, which is nice, and USB. Not quite sure what that's for connecting to a PC or just for power. We'll go through and take a look. Now the first thing that is suggested to do is to sort the components out. So I have put the capacitors here, resistors, a couple of diodes, and these little modules, little boards. They're referred to in the assembly guide here as Bob boards. So I guess that's board on board. Now again, here it says that assemble in the order given. So it's the resistors first, and then followed through by the capacitors, and then the other bits and pieces. Now the challenge here is that the actual tolerance of these resistors is mainly 1%, and they come with a 5-band color code. Even if you are familiar with the 5-band color code, these guys are pretty small. If we can get this to focus, yeah, so you would definitely have a challenge in reading those codes. Similarly, if you're not that familiar with the capacitors, it's a good idea to be able to check them. So I thoroughly recommend getting hold of one of these little testers. So all that we need to do with our various components is to just put it into the little socket here, and it tells us that obviously it's a resistor and that it's 10k ohms. So now we can reference that against the part list, and we can see that for 10k ohms that's resistors 9, 20 and 30. So then we can find the relevant locations and solder that in. And this is also obviously good for the little capacitors as well. Again, just put it into the tester, and we can see that that's 96 nanofarads. So that nano is 10 to the minus 9. So if we shift the decimal point 2 places to the left, that takes us to 0.1 microfarads. So 0.1 microfarads. We look down the list and there's a whole bunch of them, so we should have 12 of those to install. And this guy will also work obviously for other components such as the diode. So if you're not entirely sure which way around that should go, you can tell by the band obviously, and you get a nice picture on there. So a very useful device, and pretty much essential for this build. Now we've reached the point where there's the first testing needed, so the assembly of all the components bar the LCD has been done, and as I've been through, I've marked off each of the components. Now as you're going through placing the components, it's a good idea to take a look around the component that you're placing and just check that there's nothing else that's wrong. So for example, you could check the orientation of the ICs, so that pin 1 is in the right place. Check for any missing solder joints on components, and if there's anything missing. Now for example, R32 down here is missing, and also on the other side, just here, C3. Now that's deliberate. That tells you in the instructions that they're not required. But in my inspection, I spotted this trim capacitor here, which was fitted on the board already at a strange angle. You can see that this one is straight across, and in fact it's not soldered at all. So there's the place where it should be soldered, and obviously it's moved during the soldering process. So I'm going to have to fix that. The resistors and such like, no big problems there. Now these guys, although they may at first appear to be resistors, they are in fact inductors. Now when you place them in the test in the little test unit, it will tell you clearly that they are inductors, so you know what to do with those guys. A note about capacitors. Now some of the capacitors, especially the smaller ones, you don't want to spread the legs apart to stress the components. I'm just trying to find one here that's easier to see. Perhaps this one here. Now what I've done there is just with a pair of pliers to bend the leads so that they're further apart before putting them in the boards. If you just push them down, there is a danger. These ceramic guys are quite fragile, that you could crack them and cause yourself a problem that way. Now there is one of the 104 capacitors which is different to all the others, and it's very noticeably different, and that's the 100-volt one that goes in this place here. What else can I tell you? The little tiny crystal, you should note that the crystal actually has a glass seal on the end of it, so you don't want to be grabbing that with pliers, only with tweezers, otherwise you could crack that. Anything else? So the so-called bob boards, these boards which are just soldered on, it does give you in the kit a little alignment jig, but I found that to be pretty much useless. You just have to get in there. A good idea to pre-tin all of the lands, all of the pads, with a little blob of solder before you go in there, and then just put your soldering iron down onto the joint and flow some more solder, and it should bridge that gap. So now we've arrived at the point to be able to do the first testing, which is essentially just testing that the power supply is working okay before we connect up the LCD and other components. So now we're set up to do the power up test, and the first part of the test just says to double check obviously that there's no missed components or bad joints. We've done that. We've got the bob boards installed. I've closed JP2 and JP3 and 4 are open. So we're going to be powering by USB. So just power up and check the test points for +5. So let's do that. So as indicated on the instructions, just down here is the reference earth point, if you like. So if we just get the board plugged in, so a brief flash from the LED on the power supply there. Now to get into the +5 volts, there's this test point here. This gives us 4.52. It should also be on the V-bus test point, 4.88, and finally next to the JP jumper that we need to close, yes, 4.96. So we're good to go to close that jumper and do the next part of the test. So having closed the JP4, obviously powered off at the time, now we replace the USB power, and we can see now that the LED is on for the power supply, and saw some flashing on the LED there. Now all that we have to do now is to recheck the +5 volts and then press the switch, and the LED should blink once and then twice, which indicates that the bootloader is working. So once again on our 5-volt test points, a bit lower there, just on the V-bus, that's okay. Now this is the important one next to JP4, 4.99. So yep, that's all good. So now when we press the button, we get our 1 flash and then our 2 flashes. So all is good. The bootloader is loading, and we can get on with installing the LCD panels. Now it's not often that I diverge from the written instructions, but this is one occasion where I disagree. Before assembling the LCD, it says to put the connecting strips in with the longest pins into the holes. I've elected to reverse that and put the short pins into the holes. The reason being that one of the concerns, although it does tell you to make sure that the leads under the LCD are flush to avoid short circuits, it is still rather nerve-wracking to have it so close to those pins. So my solution is to put the longer pins facing upwards and to space the LCD panel away from any possible short circuits just by placing a piece of cut credit card under the module there. So that's 45 by 30 or something. So that will slide underneath the module, and then, as it does suggest, I suggest you follow it as well. Just attack the corner pins down first to make sure that it's level before you solder the whole thing. One additional pointer is that I've elected to install this programming header. Now I may never use it, but it would be impossible to install that after the LCD is in place, so I would suggest you do that as well. So now the moment of truth for the LCD installation. We're now back on track with the power up test 2. So we need to connect the power, obviously, and then check that the LCD actually lights. So far so good. Adjust the contrast. Can you see the display? So the contrast is adjusted via this little potentiometer on the back. Oh, so we've got something. I think back that off a little. That looks about right, just there. So next, press buttons. Do you see anything happening? Yes. So there's something happening there. The next thing is to check the voltages inside. So we're following through the list now and checking the voltages inside. So it says first to check AV, is that +5? So that's AV there, 4.96. V minus normal, -5, that's over here, -5. VA normal, +5. So VA is here, +5, yes. I set switch 1, 2 and 3 to ground, 10 millivolts and 1 times. I've already done that on the front. So V2 should be 0 volts, which it is. V3 should be 0 volts, which it is. V4 should be about 1.6 volts. That looks good to me. So finally, it says to adjust VPOS, can you see the trace display? So let's carefully flip this guy over. Yes, so there's a trace there. So it looks like we're ready to move on to the calibration of the test signal. So now we're at the point where we can look at the square wave output and adjust the capacitors to get the nice square wave as indicated in the instructions here. So I've already set it up. The only thing I changed was, rather than ×2, it's on ×5. Otherwise you can't see the top and the bottom of the waveform. So first part is the testing with 10 kilohertz at 5 volts. So if we plug in, we can see that there is a little bit of ringing at the top and the bottom of the waveform, and for this particular input we have to adjust the capacitor here, which is C8. So with that little trimming device, yeah, so I think that's as good as we're going to get on that test. Now I must admit that when I first tried this, I couldn't get it as good as this. I had to change one of the capacitors, which was C7. Now C7 originally, as supplied, is 120 picofarads. Now I'll put a link in the description where you can find the circuit diagram in which it actually says 100 picofarads. But I tried it with 100 picofarads and it was worse. So I found I had to increase this value, which is why there's two capacitors in parallel there, which is a 100 and a 47 picofarads. So caps in parallel are additive, so it's now 147 picofarads, and I think that gives us a reasonable result. And we'll just check, as it says here, with the other sensitivity of the input. For the fourth part of the test, we'll keeps the signal the same, but if we go into the test signal and change the amplitude to 1 volt, change that to inadvertently, that's 10,000, exit. Now we need to switch this to the 0.1, and if this needed adjusting, that looks pretty good to me. But if this needs adjusting, then it's the other variable capacitor here, which is C5. So that's the calibration complete. So here we are at the end of the kit build now, just the final assembly, and obviously I've put the two BNC connectors on, and I've elected to cut some spacers off of a piece of PVC pipe, as these connections were perilously close to the circuit board. And in the kit it was only provided one piece of screened cable for some reason. They suggest using linking wire for the main connection, bizarrely. So I found a little bit of coax cable and put that in there. For the battery, I found in my pack rat supplies this old mobile phone battery. It's only 500 milliampere hours, but the thing only draws around 200 milliamps anyway. Took a picture of that. So I think I'll put it all together now, put the top on, and then give you my final thoughts. So in conclusion, what can I say? This is definitely not a kit for the beginner. You definitely need to have some kits under your belt before you attempt this. It is quite challenging in parts, but the result I'm very pleased with. It's definitely a more capable unit than I expected, and just to sit on the bench, you know, being battery powered for those Arduino type projects, I think it's going to be very useful. And I was quite surprised, you know, to have the frequency meter function as well. Just need to knock that down. So yeah, there's many things on here which I will be exploring, and may even do a follow-up video on those things. So we go back to the oscilloscope. Yeah, very pleased with it indeed. Couple of undocumented features, or not well documented features. If you long press the level, it switches the backlight off, which may be useful in some instances. The other thing is that I got caught out. You may find that the thing doesn't switch off. Now, what I didn't read, it's not very clear in the instructions, one of the jumpers that you set in the beginning, JP2, to check some of the voltages, you need to remove that link once you've finished, otherwise the switching function does not work. Yep, in all respects I'm very happy with the unit, and suggest if you've got the skills to build one yourself.